it's a video on key features of parabolas. Okay, I sketched out a parabola right here. So a quadratic relation. So we got like the U shape. This guy's opening up. And let's just point out some key features. Okay, so one really important key feature is a root, also called x-intercepts or zeros. Has a lot of names. I'm just going to write them all. And they occur right on the x-axis. So let's just point to them. There's one there and another one there. So it looks like our roots are at, I'll just write them as coordinates. We got -2, 0, and 3, 4, 5, 6. Also -6 and 0. So that's where our roots are occurring. Okay, I should have graphed a y-intercept. Well, let's just wait for that. Let's do the vertex. Okay, the vertex is either going to be the lowest, so like the minimum point, or it's going to be the maximum point. So in this case, it happens to be the minimum point. So that's the vertex. So the vertex is at 1, 2, 3, 4, -4, 2, 3, 4, -4, -4. Crazy. So that's where the vertex is. In this case, since our parabola is opening up, our vertex is actually a minimum. Whereas if our vertex was opening down, that would be a maximum. So roots and vertex, I would say number 2 key features. Like, they're really important. Another important feature is that all parabolas are symmetrical. So I could draw a dotted line down the very middle of my parabola here. And I call this line the axis of symmetry. And it's occurring at 1, 2, 3, 4. X equals -4. Ooh, notice it's the same x value as my vertex. Not a coincidence. So the vertex runs right down the middle of your parabola. And there's a whole bunch of these like symmetrical points, we call them. So the roots, they're symmetrical. So they have the exact same y value, and they're the same distance apart from each other from the middle of the graph. And there's like, every time you have a point here, you're going to have the same point over here, like the same distance away from the axis of symmetry. Okay, so those are 3 really important key features, and if I would have kept drawing this guy, it would keep going, and eventually it would cross the y-axis, so we would also have a y-intercept, but I did not pick a very good graph to show that. But the y-intercept is when x is equal to 0. It's wherever the parabola crosses the y-axis. That's a terrible drawing, by the way. Okay, I'm trying to think of other key features, but that's all I got.